we're going to take a look at definite integrals using U substitution. Now, really, ultimately, it's no different than definite integrals without using U substitution, but there are some strategies that we kind of can use to make things a little bit simpler and kind of like two versions of what we can do here. So I'm going to show you guys kind of like my preferred method, but we could take a look at how you feel with these and how they work. So the idea here is we're going to use U substitution to integrate this function because it has that inside function, right, that t cubed plus 1. And we can't integrate this function the way that it is in its current form. Now, the thing is, we have to keep in mind, this equation, right, is built for t, right? It's built for the variable t. So that means these limits over here are the limits for t. Now, when we do U substitution, we're changing the variable, which means we also need to change the limits. So a lot of what we're going to do today is changing those limits and kind of seeing how these problems work out. Now, while we're doing our U substitution, we do that the same old way that we always would. In this case, we're identifying that U is equal to t cubed plus 1. Then we take the derivative of this. We get du equals 3t squared dt. And then we solve for dt. So we end up with du over 3t squared is equal to our dt. Now, when we go into this equation, right, we're going to be integrating. This time we've changed our variable. So we're now integrating t squared times the square root of u, and then du over 3t squared. Now, if you guys notice, those t squares cancel out really nicely. The problem is the limits of integration are no longer 0 and 2, right? They're no longer 0 and 2 because we have changed the variable. Right now we're dealing with the variable u. So what that means is off to the side, we kind of have to acknowledge this. We have to say, okay, well, when t is equal to 0, we're going to substitute that in. We're going to say u equals 0 cubed plus 1. So what that means is u is equal to 1. So our lower limit is no longer 0, it's now going to be 1. Then we also know, hey, well, when t is equal to 2, what does u equal? Right, so we know u would be equal to t cubed, so 2 cubed plus 1. So we end up with u equals 8 plus 1, or 9. So our upper limit is now 9. So it's very important that we change those limits because we're now changing the variable. So those limits no longer are equivalent, right? We've changed what our integration variable is. So we also have to change the limits of integration. All right, and really the rest of the problem continues on to be the same. We start to kind of rewrite this thing a little bit. We canceled out those t squareds. I'm going to bring that 1/3 to the front. And we need to be able to integrate the square root of u, which needs to be written as u to the 1/2, from 1 to 9, du. Now we could finish this thing out. So when we integrate, we end up with u to the 3/2 times 2/3, right? So we're dividing by the 3/2 or multiplying by the 2/3. Don't forget we still have that 1/3 out front. And we need to evaluate that from 1 to 9. Now here's the cool thing about this. We don't have to sub the u back in because we've changed the limits of integration. That 1 and 9 are built for u. So we could just kind of finish up the problem that we have right here. So what I'm going to do is I'm going to kind of clean this mess up a little bit. 1/3 times 2/3 gets me 2/9. And then u to the 3/2 is really the square root of u cubed. We're going to evaluate that from 1 to 9. So we end up with 2/9 times the square root of 9 cubed minus 2/9 times the square root of 1 cubed. Now, just kind of a little fun fact for you guys, if you didn't know this, you don't have to cube that 9 first. You could square root the 9 and then cube it later, which in a lot of cases sometimes is a little bit easier to work with, especially if you're not using a calculator. So the square root of 9 is 3. 3 cubed is 27. We end up with 2/9 times 27 minus 2/9 times 1, right? Doing this math out, we end up with 54/9 minus 2/9. So our final answer is 52/9. So just be careful with that u sub and changing of the limits. That's going to be a big key factor that we're going to be looking for. to make sure that we're comfortable with that u substitution. All right, taking a look at another example here, we'll just kind of get that practice with the same idea here. We're going to look for that u. In our case here, we have a u that's underneath a radical, so of a term underneath a radical, so that's a likely candidate for u. So we'll say u equals the sine of x, and du is equal to the cosine of x dx. And as we solve for dx, we have dx equals du over the cosine of x. And now we sub in for our u sub. We have our integral of the cosine of x times the square root of u. I'm going to just change it to u to the 1/2 here, times du over the cosine of x. So we can see nicely those cosines cancel, but we still need our new limits. So again, off to the side, we're going to say, well, our lower limit is 0. So if x is equal to 0, u is equal to the sine of 0. Right, and if we look for the sine of 0, the sine of 0 radians is 0. So our lower limit's going to stay the same, and then we're going to check for that upper limit. So we're going to look at that pi over 2. So when x equals pi over 2, u equals the sine of pi over 2, and the sine of that 90-degree angle, or that pi over 2 radians, u would be equal to 1. So we're really integrating this thing from 0 to 1. Okay, so just kind of cleaning this up a little bit here. We're integrating from 0 to 1 of u to the 1/2 du. And there's nothing else fancy going on here. There's no other coefficients. We actually just have to integrate this fractional exponent, which isn't too bad. We end up with u to the 3/2, right? Add 1 and then divide by the new exponent. So divide by the new exponent or multiply by the reciprocal. And then we evaluate that from 0 to 1. So I'm going to, again, just rewrite this thing as the square root of u cubed over 3 from 0 to 1. So what that means is we have 2 times the square root of 1 cubed over 3 minus 2 times the square root of 0 cubed over 3, or 2/3 minus 0, or our final answer of just 2/3. So ultimately, this process I'm mostly concerned about, right, we're pretty good with our u sub at this point, but I'm mostly concerned about those limits of integration, and then understanding too that, hey, we have these new limits that are good for you, no need to substitute the x or the other variable back in, and you guys are good to go. So give it a little practice and let me know how it goes.